In this video, we'll look at how to do the Fibonacci sequence in NMC. The next number in the Fibonacci sequence is the two previous numbers added together. We'll output the first 10 iterations of the Fibonacci sequence, and we'll start with 0 and 1. This means the program will run for 10 iterations. Each iteration will add the previous numbers together. To start with 1 and 0 and be able to manipulate them, we have to set them as the variables a and b. We want 10 iterations, so we have to loop the main part of the program 10 times. The main part of the program outputs a and then sets the variable term to a plus b. It sets a to b and b to term and then loops. Each time a is set to the next term in the Fibonacci sequence. Here's an example as if we were on the 5th iteration. We output 3 and then set term to 3 plus 5, which is 8. We then change the variable a to b, which is basically turning the 3 to 5. It then sets 5 to 8, which is b to term. On the next iteration, it'll output 5 and then set term to 5 plus 8, which is 13. It then changes the 5 to 8 and then sets the 8 to 13. This table shows what each variable will be set as for each iteration. This is the code we'll be using. As you can see, it outputs the first 10 iterations of the Fibonacci sequence. This is the NMC code for 10 iterations of the Fibonacci sequence. As you can see, the program outputs the first 10 iterations, and if you change what the variable n is set as, you can change the number of iterations that are done. So if I use that, it outputs 14 iterations. If I set it to, let's say, 18, it will do 18 iterations. The reason we get a negative number here is because NMC cannot handle numbers that are larger than 3 digits, and the 18th term for the Fibonacci sequence is over 3 digits. This diagram shows how the pseudocode is implemented into NMC. The blue part are the variables a and b, which is set to 0 and 1. The green part is what counts the number of iterations. N is the number of iterations you want. Y is just used to easily subtract 1 in NMC. At the top we check if n is 0. If n is 0, then it means the number of iterations we want are done. We count down from 10 by subtracting 1 from n each time. The other part is where a is output. The red part is where the next term is set. In our pseudocode we use the word term, but in our NMC code we use box 99. Every iteration, b is loaded and added to a and stored in box 99. A is then set to b and b is then set to box 99. This diagram will be in the description.